Okay guys, hi. This time I will show you how to convert for pressure, gas pressure in this case. In this first example we have ATM to PSI and then NTM to pascals. So these are our conversions. I'm gonna leave them over there so we can start. Remember to leave the units in opposite positions. ATM PSI is the last one. In one ATM, 14.7 PSI. So the answer is 18,000. No, 18.38. We round it, okay? PSI. Now we have the second one, 1.25 ATM times. We know the conversion factor between ATM and pascals is this, okay? In one ATM, we have 1.013, 25 if you want, times 10 to the 5th power pascals. And this gives me 126,656.25 pascals. Okay, let's do the next exercises. We always start with the given. Conversion factor between millimeters of mercury and torrs is the first one, 1 to 1, so we basically don't need to do it. But in case you want to show a procedure, this is how it's done. In 1 millimeter of mercury, we have 1 torr. So the answer, it's the same, but in torrs. Now, the second part. Okay, from millimeters of mercury to PSI. So we have millimeters of mercury here, and we have PSI here, so we need to do a two-step conversion. So we say it's better if we convert to ATM and then from ATM to PSI. So we say there are 760 millimeters of mercury in one ATM, and also in one ATM we have 14.7 PSI. This is equal to 826 times 14.7 divided by 760. 15.98 PSI. Let's continue. 86,000 pascals to PSI. Okay, from pascals to PSI, we have this conversion. So pascal should be written in the bottom. We say 6.893. This conversion factor, I rounded it. Let's do it in the calculator. 12.48 rounded PSI. The second part, 86,000 pascals times. Okay, now from pascals to torr, I don't have a direct conversion factor, so I have to, the best idea is from pascals to ATM and from ATM to torr. So we say that there are 1.01325 times 10 to the 5th power pascals in 1 ATM times in 1 ATM there are 760 torr. 86,000 times 760 divided by 1.01325 exponential 5, 645.05 torr. Now let's do the last part. 19,000 psi to ATM. Okay, from psi to ATM we have this direct conversion factor. We say there are 14.7 psi in 1 ATM and it's done. 1,292.52 rounded ATM. Now from psi to millimeters of mercury, we say 19,000 psi times. Okay, the idea, we don't have any direct conversion factor, so the idea will be to convert from psi to ATM and from ATM to millimeters of mercury. I know I have my ATMs here, but in case that you don't have ATMs, you have to do a two-step conversion. That's exactly what I'm gonna do right now. So I know that there are 14.7 psi in 1 ATM, and I also know that in 1 ATM I have 760 millimeters of mercury. I perform this in the calculator and I will get 982,312.93 millimeters of mercury. Okay guys, that's it for conversions. Okay, now we're gonna start with the first law about gases, that is the Dalton's partial pressures law, that says that the total pressure PT is equal to pressure 1 plus pressure 2, pressure 3. I mean, it is the sum of all the pressures of all the gases in the mixture. Okay, so if in that mixture I have 3 gases, the total pressure will be pressure of the first plus pressure of the second plus pressure of the third gas. And if in a mixture I have 20 type of gases, I'm going to add the 20 pressures of each gas to have the total pressure of my mixture. Now let's do one example. What is the partial pressure of nitrogen in a mixture of carbon monoxide, carbon dioxide, oxygen, and nitrogen at 1 atm if the pressure of carbon monoxide is 66 torr, the pressure of carbon dioxide is 6.5 torr, the pressure of oxygen is 160 torr, and as I need to find nitrogen, this is going to be my unknown. So by definition, I know Dalton's partial pressure is the total pressure, the sum of the individual pressures. In this case, I have carbon monoxide, carbon dioxide, oxygen, and my unknown, which is nitrogen. So remember, the total pressure is 1 atm. It's a given. So total pressure is 1 atm, and we start replacing all the givens. But take a look, I have ATMs here and I have torrs in the other side. So basically the idea is to convert or to have the same units. I didn't ask you to give me the answer in any specific unit. In my case, I will express the answer in torrs, but also in ATM. But as you can see here, I have ATM and I have torrs. But we need to have the same unit. So it is easier to convert from ATM to torrs than all these individual torrs to ATM. That's why I did it in this way. So from 1 ATM, how much is that in torrs? According to my units of pressure in 1 ATM, I have 760 torr. I just did the conversion. But I need to find the pressure of nitrogen. So here, 66 plus 6.5 plus 160 gave me 232.5 torrs. And then I just isolate for nitrogen, and I have, this one was adding, go to the other side to subtract. 760 minus 232.5 torrs is equal to 527.5 torr. Now, what if I say, express the answer in ATM? So, you have to convert this final torrs into ATM by using the conversion factor between ATMs and torr, which is this one. And you cancel the same units that are in opposite position. So basically, Dalton's partial pressures is very simple. It's just adding the individual pressures to have the total pressure of it. So guys, I hope that you have liked the video. It's short, but I think you're going to understand a lot. Thank you for your attention. Have a good day.